It's Earth Science time. This is Norris Teaches Science, another Earth Science Edition video starring me, Mr. Norris. Today, in this Astronomy Edition video, we're going to talk about the Sun. And so by the end of the video, you should say, I can discuss how the Sun works. So a little bit about the Sun. We all know that the Sun's a star. The Sun is the closest star to Earth, but the Sun does have layers to it, just like the Earth has layers. And when we talk about the lithosphere, we're going to talk about the Earth layers, but right now let's talk about the Sun layers. And so we're going to go from the inside of the Sun outward. So the first part we see is the core. This is where energy is produced. It's where all the reaction stuff happens to produce the energy for the Sun. Then if we come out, we have the photosphere. The photosphere is the surface of the Sun. The chromosphere is this thin layer of hot gas right above the photosphere. And then you have the corona, which is all the shiny part. It's the outermost layer that is very, very weak. Now, the Sun does have some features to it. You got the sunspots. That's these dark areas on the Sun. There are dark blotches on the Sun, and they're actually cool areas. Cool in a sense. They're still really hot. Like if you were in them, you would die because you would just, burn up. But they're cooler than their surrounding areas. You have solar flares. That's what you see right here. They're brief eruptions from the Earth's surface. They can cause electromagnetic disturbances on Earth. That means messing with anything that deals with electricity or deal with magnets, so like cell phones and computers and satellites and TV and internet. It's a whole bunch of stuff. You got solar prominences. They are large, bright, gaseous features extending outward from the sun's surface. And then you have coronal mass ejections, which are large explosions in the sun's corona. You can see in the GIF here one of them happening. Now, the sun is not just stationary. Yes, the Earth revolves around it, all the planets revolve around the sun, but the sun isn't stationary either. The sun kind of gets pulled in all the directions by the planets' gravity because we do have a gravitational pull too. It's a slight motion. You would never notice it in a daily thing. It also orbits the solar system's barycenter. And something else mentioned up here, it is not stationary in the galaxy either because the galaxy is moving. So we're moving along with the galaxy at the same time. We're moving as the galaxy moves away from wherever singularity was, and we're rotating around because we're in a spiral galaxy. Now the sun does produce energy, and the sun produces energy by fusion. This is when atoms combine together. So in the sun, it's hydrogens combining to create helium. So it's that's that purpose. While on Earth, we use something the opposite of it called fission. This is when we split atoms, and we do this with uranium. We split the atom, and it creates nuclear powers at our power plants. We're going to talk more about nuclear power when we get into some of the renewable energies and non-renewable energies and stuff that we mine out of the Earth's surface, stuff like that. Now, remember, the sun is the center of the solar system. Coming out from the sun, we have our inner planets, which is Mercury, Venus, Earth, where we live. We're the third rock from the sun, then Mars. Then the outer planets come in as Jupiter, Saturn, Uranus. I know what you're thinking. I said it the correct way. And Neptune. And then there's Pluto out there. When I was a kid growing up and I was in school, Pluto was a planet. It's no longer considered a planet. It's considered something called a dwarf planet. So it's not a planet in general. It's up to you what you believe. I still think of Pluto as a planet. Other items in the solar system, we have comets. These are ice and dust that get a tail closer to the sun. You can kind of see that right up here. There's a comet. The famous one is Halley's Comet. Then you have meteoroids. These are rock objects traveling through space. they become meteors when entering the atmosphere. Those are what we think of as shooting stars. There's other planets that we haven't found. We think there's some more dwarf planets out there past Pluto. And there's moons on other planets. Jupiter has a moon, Saturn has a moon. So there's moons out there other than ours. They're called satellites on other planets. We call ours a moon. But there's the moons of Jupiter as well. Now, what does the sun emit? The sun does emit energy out of it. We know that it produces the energy by fusion, but emits it as electromagnetic radiation. These are different waves of light, and they're based off wavelengths and frequencies. And we get the light this way, and we get our heat this way. The Earth is heated by the sun and through electromagnetic radiation. And all the waves on that are electromagnetic radiation are arranged on the electromagnetic spectrum. And here's the spectrum. We call it an EM spectrum for short. So you have radio waves, which have the lowest energy um, right here. And then you have infrared, followed by which we use to see body heat, visible light, which are Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. They combine together to create white light. After visible light is UV rays. This is the stuff that will cause you to have a sunburn. X-rays, most people usually know about X-rays. They've had an X-ray. And the wave that has the most or the highest energy are gamma rays, and they are really bad to come in contact with. But that's a type of electromagnetic wave. So this is a little bit about the sun. The sun does a whole bunch for the planet, and we're going to talk about how the sun um, comes together with everything else to make Earth livable. But I hope you learned something. I hope you learned something today. And this is Mr. Norris, and he is signing out for this video.